Okay, so in the second piece, we're going to go backwards. If we have negative 7 pi over 4, so then this time we have 0 here, negative 90 degrees, negative 180 degrees, negative 270, and then loops around to negative 360. So remember, when we have negative angles, they go clockwise around the unit circle. Okay, so once again, when you're looking at the angle given to you, you want to look at the pi over and then whatever the denominator is. So this time it's pi over 4. So pi over 4, going back to our sheet, is equivalent to 45 degrees. Okay, so if we went back to this sheet here, 45 degrees is equivalent to pi over 4. So that means that we're doing negative 7 times 45 degrees. Okay, so negative 7 times 45 degrees is going to give us what? Negative 315. Okay, so you should be able to figure that out without a calculator. Okay, it's doing simple multiplication longhand. Okay, so then we have to figure out, well, what quadrant is that in? So if I start here in standard position as usual, and I go around the circle or the quadrants clockwise, and I pass negative 270, and then it ends up being right about here. Okay, it doesn't really matter exactly where you put it. Okay, it probably should be a little bit more in the middle since it's a 45-degree triangle. So I'm going to fix this just so it fits a little bit better. Okay, and then again, I draw my triangle to the x-axis. Okay, to the x-axis, and then here's where my reference angle is. So this would be my theta, but since we already know it's 45 degrees, I'm going to put 45 degrees right here. Okay, and then we need to take a look at our 45-degree triangle. So if you have forgotten it, I'm going to place it right here. Our sides are 1, 1, it's an isosceles right triangle, and then my hypotenuse is radical 2. So because this is in the first quadrant with all students take calc, my sides are both positive, and the hypotenuse is always positive. Okay, so 1, 1, square root of 2. So I don't have to worry about any of my sides of this triangle being negative because we're in the first quadrant. X is positive and so is Y in the first quadrant. Okay, so let's go through and it says find all 6. So sine of theta, opposite over hypotenuse, 1 over radical 2, and then we're going to rationalize, which means multiply each of them by radical 2. So we get radical 2 over 2. Okay, same thing's going to happen with cosine. Okay, so I'm going to get the same exact answer, 1 over radical 2, and we get radical 2 over 2. Okay, always make sure you rationalize. Okay, and it ends up being the same since it's an isosceles right triangle. Okay, and then we're going to go for tangent, which is opposite over adjacent. So opposite over adjacent, 1 over 1, and we're going to write this as 1. Okay, and now we're going to do our reciprocal. So I'm going to do cotangent first since that's the easiest. I'm just going to take the reciprocal, which is just 1. Okay, adjacent over opposite. Now when I do secant, okay, instead of going back to the radical 2 over 2, I would want to go to the unrationalized form. Okay, hypotenuse over adjacent, because to me that's going to be easier to just write radical 2 over 1, which is just going to be radical 2. Okay, if I flip radical 2 over 2, then I'm going to have to rationalize and then simplify a whole bunch of stuff. Okay, and then the same thing with sine, that goes with cosecant. Again, I'm going to go back to the unrationalized part, and that would leave me with radical 2 over 1, which is radical 2. Okay, so those are our final answers, finding all 6 trig functions. Okay, just practicing those. All right, and 45-degree triangle is pretty easy. And then again, being in the first quadrant, everybody is happy. So every single one is positive. Okay, so the next question that you're going to answer in Nearpod is going to be the following question. Evaluate all 6 trig functions of theta when the angle theta is equal to negative 2 pi over 3. So remember, you're going in the clockwise direction and you're looking at the reference triangle of pi over 3. Okay, so give that one a try.